option, like, than the linear?
Over time. You just told me.
You just told me.
That, it make more money.
But
What you
but
say?
why? Like, what's going on that
Like the rate of, I want to say the rate of change is
it's increasing,
increasing
right?
more. Yeah, that's
Right.
the word I look for, increasing.
Okay, so on the back side, okay, everyone look at the back. We are gonna take some notes. So what I want y'all to do, split this part into two sections. We're gonna do a linear, we're gonna have notes for linear, and then notes for exponential.
What?
We got to write it on the back.
Yeah, there's a spot that says notes from whole class discussion, this is what I'm talking about. So these are gonna be your notes for, we're really paying attention to the things that are similar and different about these. Okay, so when we're talking about, we had a table over here for the linear function. How much money do we have on day 0?
0.
Okay, and then on day 1, we had how much?
60 racks. 60 racks.
Okay, and day 2,
120.
okay. So, what's going on? What can we conclude from the table?
The constant rate of change is 6,000
Right, so that's a constant.
at a rate of change.
Okay, so maybe just show that additive change. Okay, because when we have an exponential function, what kind of rate of change is it? Right, so when you're making your table for your exponential functions, you want to show that it's constantly multiplying. And you really only need to write enough days to show that pattern is going on.
Oh my God, that was up. He off the earth.
Okay, so for those of us, did everybody graph it in here?
I did.
Okay, so when we graphed it, let's see, so I'm going to draw another line. I'm going to label this for the table. I'm going to label this for the graph. Okay, so when you graphed option 1, what did it look like?
A straight line.
It looked like a straight line, right?
Just straight up.
Okay, and we do call this a line. But then when we graphed this option 2, what did it look like?
It was like
It went constant, then when it got to the end, it just
stopped.
curved
Right, it
up.
started and then it curved, right? So this is called an exponential curve. So also make note of that. Is there anything you want to add for the graphing part? Or just like to know the shape of the stuff?
That one, so there was one thing I want to talk about. Does a line always have to increase?
No.
No, it can also decrease, right? So we would say that this slope is what kind of slope? Positive. This one is negative. In a similar way, hey y'all, you might want to pay attention to this, group 1. This is an exponential curve. You see how it's increasing? It can also decrease. Typically, it doesn't go below the y-axis, or x-axis, that's my fault. It can, we'll talk about those later. And so when it's increasing, we would say that it's growing. And when it's decreasing, we call it decay. I don't think we even talked about that detail.
Well, we didn't talk about the graph in any other class.
Yeah, I think, well, we didn't get to the graph. I meant when you and I prepped for this.
Oh, yeah.
Yeah, so do note the difference. And so you may actually want to do 2 small different graphs, but you can have exponential growth. So this one is growth.
Well, somebody phone is
I know, man. Exponential growth there, and this one is exponential
I don't care.
decay. That's the only thing I would add there. Guys, please don't forget your objectives, and I don't think you mentioned this, or just, at least at this point, don't forget your objectives. What are we trying to do? Why are we creating this graphic organizer of sorts?
So we can create equations with linear and exponential functions.
Using graphs and tables.
So if we're gonna use those graphs and tables, we gotta know the difference between linear and exponential in tables and in graphs, so we gotta pay attention to those things.
She don't got no equation for exponential.
That's next.
Alright.
Okay, so let's talk about, so we have, so the general, equation for a linear function, we're using y equals a plus bx. Did anybody, which I know I talked about this with some groups, but so when you're making, for the general equation for the exponential function, here a is our y-intercept. Is that, did you look it up? Is it?
Well, we're just gonna call it the general form of the
Okay.
exponential.
So here,
That's still sloped intercepts, but for the exponential, we're gonna call it general form.
so the equation of the equation, we still have a y-intercept and then a constant factor, right? So we need to have those in our equation. So if we have the y-intercept, and then this function is not constantly adding, it's doing, right, we're multiplying, not x squared, b raised to the x for our, so our exponential function, because remember we can substitute in values for x, because that's our number of days, and then the output would be how much money you would be making on that day.
Now, I do like what you were thinking, Khalil. Why'd you say x squared? Just saying stuff?
No, I think it was going by 2.
Okay. And so I will point out though, like also if you say x squared, you're thinking about an exponent, right? Which an exponent is showing repeated what? Multiplication. But notice the exponent needs to be. What are you giggling about? What does the exponent need to be? Ryan, man, can't keep hold of himself. I appreciate his efforts. I love how he's trying.
You know what I'm saying? But I'm checking you, I just laugh.
He's so serious, bro. He was just laughing,
Why you gotta laugh at that boy? He's
So-
trying. I love it.
I know that.
Okay.
You may make a note that b is your constant factor, or for exponential functions, we also call this the common ratio. So 2 is our common ratio in this problem.
Ken, you look like you had a question.
I was about to say, is it a equation?
Huh?
Would it be an equation or a problem? That's what I was about to say. It don't matter.
I mean, a problem is just like something that you have to tackle. Like, look at it. Is it an equation?
No.
Y equals a times b to the x. You don't know if that's an
Is
equation.
it equal? You got equation, man.
Okay.
Yeah. Or you said common ratio though, or common factor?
Yes. Yes.
Word.
Okay.
Yeah, b
We
is
have
a common factor.
one more section I want y'all to add to your notes is the rate of change. So I'm just gonna write it over here. I'm gonna put rate of change. So for a linear, we have a what kind of rate of change? Linear functions.
Constant.
Okay.
Yeah, constant add. I ain't got no work.
I wrote mine.
Oh, I'm gonna put this on your paper
We ain't gonna work out.
And then we the rate of change is shown through what in that function? Right, the multiplication of the slope.
Oh. Yeah.
Because remember, we don't call, the exponential functions don't have a slope.
Why you trolling, bro? The camera on lock you in, bro.
Okay, and then for exponential functions, what kind of rate of change? What kind of multiplication?
Yeah.
Right, so it's a constant multiplicative. and then instead of a slope, we're multiplying by that common factor.
Now, what?
What is it?
Exponential decay? I will point out, what do you do with factors? Do y'all know? What are the factors of 6?
Find these kind of multiple.
3 and 2?
3 and
So 3 and 2 are factors, meaning you're doing what with the 3 and 2? You are
multiply.
Oh, so when we say common factor, it's something that we're as a constant factor, something we multiply by.
And constant factor is like a constant multiplication within those numbers.
The common factor is the constant multiplicative rate of change.
Oh, you said.
Common factor is just the name of the constant multiplicative rate of change.
Alright, usually big words, it's time to go, y'all. It is time to go.
It's true. Just a heads up, you don't have any real new homework. I'll give graphic organizers back tomorrow, because you will have a graphic organizer submission due on Tuesday.
Huh?
If you have missing homework, you need to work on that ASAP.
You said work on the back homework.
If you're missing any homework, you need to work on it. That's all you got. Thank you, sir.
I don't wanna skip it.
That's right.
I learned something. I'll find it.
Yeah, you learned something, didn't you?
We didn't have no problem.
Khalil, you were so much more awake and alert and learning this year than you were your freshman year. I'm loving it. Thank you, Jay.
Bye, have a
See you,
good
sir.
one.
Seem drained at the end of that one. Tim, you seem drained at the end of that one. You good?